Hello students, this is sixth lecture of differential calculus. So even this is the third lecture of successive differentiation. So in first two lecture we have discussed how to find the nth derivative of the given function. So we will continue with the same, and today we will discuss some more examples, more uh, uh, functions like trigonometric function, how to find the nth derivative of trigonometric function. So let us start with if y is equal to sine ax plus b, where a and b are any real number. A comma b belongs to R. So prove that the nth derivative of this function yn is equal to a raised to power n sine n pi by 2 plus ax plus b. So function y is given, y is equal to sine ax plus b. We have to prove that its nth derivative yn, that is equal to a raised to power n into sine n pi by 2 plus ax plus b. Okay, so this is theorem. Let it be. Now we prove this. So what is given? Given function y is equal to sine ax plus b, where a, b, any two real number, any real number. So b, what we have to prove, required to prove, or we have to prove that yn is equal to a raised to power n sine n pi by 2 plus ax plus b. So let this be first equation and this be second. So differentiate, even what we do, we use principle of mathematical induction to prove this. We use principle of mathematical induction, that is PMI, on n, that n in n, to prove this result. So let us start for y1, for n equal to 1, for n equal to 1, differentiate equation 1 both sides with respect to x, we get. So in principle of mathematical induction, what we do, we prove that the result is true for n equal to 1. If it is true for n equal to 1, then we assume that the result holds for n equal to some number k, natural number k. Then we have to show that it is also true for n equal to k plus 1. If it is true, then we can say it is the result holds for every n, for all n belongs to natural number. So first we have to show that the result is true for n equal to 1. So we differentiate equation 1 both sides with respect to x, we get y1. y1 is equal to derivative of sine is cos ax plus b. Again differentiate ax plus b, we get a. So we can write this as a, and we know that sine 90 plus theta is cos theta. So we can write this as sine pi by 2 plus ax plus b. So look at equation number 2. If we put n equal to 1 here, so y1 is a ki power 1, that is a, so we get a. Sine 1 into pi by 2, so pi by 2 plus ax plus b. So we get this a sine pi by 2 plus ax plus b. It means the result is true for n equal to 1. Now assume that it is true for n equal to k, where k is any natural number, right? N equal to k. Then yk, what is yk? So a ki power k, we put n equal to k in equation 2, yk equal to, yk means kth derivative, that is a ki power k into sine k pi by 2 plus ax plus b. This is yk. Let this be equation number 3. Now we have to show that this result is true for n equal to k plus 1. Now we have to show that the result holds for n equal to k plus 1 also. That is what we have to prove. We have to prove that yk plus 1 is equal to a ki power k plus 1 sine k plus 1 pi by 2 plus ax plus b. So this we have to prove. So we put this in bracket. This thing we have to prove. So what we do now, we differentiate equation number. How we find yk plus 1? Yk plus 1 with k plus 1th derivative. So we have already given in equation 3 yk, kth derivative. If we one more time differentiate with respect to x, then we get yk plus 1. That is k plus 1th derivative of 1. So we do differentiate one more time equation number 3, right? Differentiate both sides of equation 3 with respect to x. We get y k plus 1, that is equal to a ki power k. Now what is the derivative of sine? That is cos k pi by 2 plus ax plus b. So this is the k, this is the derivative of sine. Now once more time we differentiate. We again differentiate k pi by 2 plus ax plus b. Then we get a. So a into a ki power k. This is a ki power k plus 1. Now again cos, this is theta, cos theta. So we can write this as sine 90 plus theta. So we can write sine pi by 2 plus this k pi by 2 plus ax plus b. Now we can combine pi by 2, a ki power k plus 1 sine. We can take pi by 2 to be common. So we get k plus 1 pi by 2 plus ax plus b. Right? So we get this. If you look at the expression in rectangular box, so we find out that yk plus 1 is equal to a ki power k plus 1 sine k plus 1 pi by 2 plus ax plus b. Thus, the result holds for n equal to k plus 1 also. It means therefore by principle of mathematical induction we can say equation 2 means that we have to prove the nth derivative of this. Equation 2 holds for all n belongs to natural number. So this result is true for every n in one. That is yn is equal to a raised to power n sine n pi by 2 plus ax plus b. So this is one of the important article in differential calculus. So pause, revise, and then proceed. Now let us discuss some more question based on this. Note, if y is equal to sin x, then the nth derivative of y is, now you can observe here y is equal to sin ax plus b. So here a and b be any real number. If we take b to be 0 and a to be 1, so we get y equal to sin x, right? So if we put y a equal to 1 and b equal to 0, so what is the derivative of and the derivative of sin x? A ki power a is 1, 1 ki power n, that is 1. Sin n pi by 2 plus 1 into x plus 0. So we get sin n pi by 2 plus x. So we can use this. So directly we can write nth derivative. If y equal to sin x, then nth derivative is sin n pi by 2 plus x. Go through the general result, sin ax plus b. Put the value of a is 1 and b is 0. You find out. Even you can also prove this, right? This is, so some example. You can tell me quickly what is, if y is equal to cos sin 3x, then what is yn, nth derivative of y? Now what we do here, we take a equal to 3 and b equal to 0. So we can write this as 3 ki power n sin n pi by 2, n pi by 2 plus 3x. Let us discuss one more exercise 2. If y is equal to sin 2x plus 3, then what is yn? Here a equal to 2, b equal to 3. So 2 ki power n sin n pi by 2 plus 2x plus 3. Right? So if y is given, sin y equal to sin of ax plus b is given, then directly we can write the nth derivative of this. Let us do some more example. If y is equal to sin 4x. Now tell me what is yn? Quickly, what is yn? Write your answer in the notebook and check. Pause the video, write your answer in your notebook and then check. So this is a is 4 raised to power n sin n pi by 2 plus 4x. So I will give you some examples. Exercise number 4. First part, if y is equal to sine 2x, sine 5x, sine 2x plus 5, sine 3x minus 4, sine cx plus d, sine 7x, sine x plus 3, then these are some function, then find y(n). You can solve these and also share our answer in the chat box. Okay? So it will help the other viewers to check their answer. So now, can someone tell me, can someone guess what is my next question? Yes. So next question is, so next, you can say next article or theorem. If y is equal to cos ax plus b, where a b be any real number, then prove that yn is equal to a की power n cos n pi by 2 plus ax plus b. So I leave this article to you to prove yourself. Prove yourself. If the result is clear to all of you, previous result is clear to all of you, then there is no difficulty to prove this. So again, some examples based on this. If y is equal to cos x, then what is yn? If y is equal to this, then nth derivative of this function is, can anyone tell me? Yes. So a is 1. So 1 की power n is 1 cos n pi by 2 plus x. B is 0. Very good. So exercise 2. If y is equal to cos 2x, then what is yn? Yes, 2 raised to power n cos n pi by 2 plus 2x. Very good. So if exercise 3, if y is equal to cos 3x, then what is yn? 3 raised to power n cos n pi by 2 plus 3x. So now you try. If y is equal to cos 4x, cos 5x, cos 6x, cos 7x, cos 2x plus 3, cos 3x plus 4, cos x minus 1, cos x plus 2, and so on. Right? Then find yn. Again, you can write your answer in the chat box. If you face any difficulty, you can ask your question in the chat box. Okay. So these are some. So again, use PRP, pause, review, and revise, and then proceed. So these are some questions based on trigonometric function. If y is given sin ax plus b or cos ax plus b, then we find the nth derivative of sin ax plus b and cos ax plus b. Okay. So let us discuss one more article, one more result. If y is equal to e की power ax sin bx plus c, then prove that yn is equal to a square plus b square की power n by 2 e raised to power ax into sin bx plus c plus n time tan inverse b by a. So some results, some formula you have already know about sin a plus b. Sin a plus b, that is equal to sin a cos b plus cos a sin b. So we use some formula in this when we prove this article. Even we also use if we take in parametric form, if I take x is equal to r cos theta and y is equal to r sin theta, if x and y are given, then if we square both x square plus y square and add, then we get r square cos square theta plus r square sin square theta, and that is equal to r square cos square theta plus sin square theta, that is 1. So we get r square. So x square plus y square equal to r square, or r is equal to x square plus y square की power 1 by 2. Also, if we divide this, if this is 1 and this is 2, if we divide y by x, then we get r sin theta upon r cos theta, so we get tan theta, and theta is equal to tan inverse y upon x. So these are some results which we use while we prove this article. So let us come to the proof. What is given? Given that y is equal to e raised to power ax sin bx plus c, and we have to prove that yn, that is equal to a square plus b square की power n by 2 e की power ax sin bx plus c plus n tan inverse b upon a. So let this be 1 and this be equation number 2. So again we use principle of we shall use principle of mathematical induction on n to prove this result. So differentiate. First, we prove that this result is true for n equal to 1. So for n equal to 1, differentiate equation 1 both side respect to x, we get. So what is y1? Y1 is e to power ax. We use first into second. First function is e to power ax, second is sine bx plus c. So what is the derivative of sine bx plus c? It is cos bx plus c into b plus derivative of e to power ax, that is a e to power ax into sine second function as it is sine bx plus c. So if we take e to power ax to be common, if we take e to power ax to be common, then we can write this as b cos bx plus c plus a sine bx plus c. So this is y1. So put b equal to r cos alpha and a is equal to r sin alpha. So here we put this b to be r sin cos alpha and this a to be r sin alpha. So squaring and adding. So squaring and adding, we get b square plus a square is equal to r square cos square alpha plus r square sin square alpha. So that is equal to r square cos square alpha plus sin square alpha, and that is equal to r square. So we get b square plus a square is equal to this, or this implies r is equal to a square plus b square to power 1 by 2. Also, if we divide a by b, then we get r sin alpha upon r cos alpha, that is equal to r and r cancel out. So we get 10 alpha. So this implies 10 alpha. So alpha क्या हो जाएगा? Alpha is equal to 10 inverse b by a. So these are some important we put in the box. So now come to this equation, let this be equation number 3. So when we substitute the value of b and a in the bracket of equation number 3, in the inner part of equation number 3, we get y1. What is y1? E to power ax b equal to r cos alpha into cos, so here we put b equal to r sin alpha, not cos alpha. So we put b equal to r sin alpha and a equal to r cos alpha. A equal to r cos alpha. So b square plus a square is, so you can change this. So this is sin square alpha, sin square alpha, cos square alpha sin square alpha cos square alpha. So we get r square. So r equal to this. But here also, instead of b by a, so here we find b by a. b by a is equal to r sin alpha upon r cos alpha. So we get, this implies b by a equal to tan alpha. This implies alpha is equal to tan inverse b by a. Okay. So make some change in this part. So now substitute these and we get y1. y1 is equal to e की power ax r sin alpha cos bx plus c plus r cos alpha into sin bx plus c. So take r to be common. So r e की power ax into bracket sin alpha cos bx plus c cos alpha sin bx plus c. So it is sin a cos b plus cos a sin b. This is nothing but sin a plus b. So we can write sin a plus b, that is bx plus c plus alpha. So this is sin bx plus c plus alpha. Now r is equal to a square plus b square की power 1 by 2 e की power ax sin bx plus c and alpha is tan inverse b by a. So this is our y1. So if we compare this with yn, when we put n equal to 1, we get y1 is equal to a square plus b square की power 1 by 2. So we get a square plus b square की power 1 by 2 e की power ax. So e की power ax is here. Then sin bx plus c plus n is 1. So bx plus c tan inverse b by a. So we get bx plus c tan inverse b by a. It means the result is true. The result in equation 2 in equation 2 holds for n equal to 1, right? So for n equal to 1, the result is 2. Now what we do in the next step is assume that the result is true. Where result holds for n equal to k. So what is yk? Yk is equal to a square plus b square की power k by 2 e की power ax sin bx plus c plus k time tan inverse b by a. So this is equation number 4. Now what we have to do? We have to show that we have to prove that it is true for n equal to k plus 1. So that is yk plus 1 is equal to a square plus b square की power k plus 1 by 2 e की power ax sin bx plus c plus k plus 1 tan inverse b by a. So this we have to prove. Right? So what we do? We differentiate equation 4 both side respect to x. We get we get yk plus 1. That is a square plus b square की power k by 2 e की power ax, the derivative of sine bx plus c. Again we use first into second, so we can take a square plus b square की power k by 2 to be common. So first is e की power ax, and this is our first function, and this is second function. So we can differentiate sine, derivative of sine is cos bx plus c plus a tan inverse b by a. Again differentiate bx plus c plus k tan inverse b by a, we get b plus e की power ax is a e की power ax into sine bx plus c plus k tan inverse b by a. So we can take e की power ax to be common. So a square plus b square की power k by 2, e की power ax to be common. Again we put b to be, what is b is r sin alpha, b is r sin alpha, a is r cos alpha. So we put b is r sin alpha into cos bx plus c plus k tan inverse b by a plus a is r cos alpha sin bx plus c plus k tan inverse b by a. So we take r to be common. So a square plus b square की power k by 2 e की power ax into r is common, and again in bracket it becomes sin a cos b plus cos a sin b. So again sin a plus b, sin a plus b. So I can write sin bx plus c plus k tan inverse b by a. This is capital A, and b is alpha. So r is already a square plus b square to the power 1 by 2. We have already find out the relation between relation of r in term of a and b. So we can write a square plus b square to the power k by 2 into r is a square plus b square to the power 1 by 2 into e to the power ax into sine bx plus c plus alpha k tan inverse b by a, and alpha is tan inverse b by a. So this is a square plus b square, a square plus b square, base are equal, powers are added. So we can write a square plus b square की power k by 2 plus 1 by 2, that is k plus 1 by 2 e की power ax, and then sine bx plus c plus take tan inverse b by a to be common. So k plus 1 tan inverse b by a. So the result is 2. That is the, we have to prove this yk plus 1 is equal to this. Thus the result into equation 2 holds for n equal to k plus 1 also. Therefore, by principle of mathematical induction, it is true for all n in n. All n belongs to nothing. Therefore, if y is equal to e to the power ax, sin bx plus c, then yn is equal to a square plus b square की power n by 2 e की power ax sin bx plus c plus n tan inverse by. Go through this result. This is very important result. So pause the video, revise, and then proceed. PRP. So let us quickly discuss one question based on this. One example. If y is equal to e की power 2x sin 3x plus 4, if it is given. Now if we have to find yn find करना हो तो क्या करेंगे? We use this result. Here e की power a, this is our a, this is b, this is c. So compare the result, then we find yn. Yn is a square plus b square. So a is 2, so 2 square plus b is 3 square की power n by 2. E की power ax, e की power 2x as it is, sin bx, b is 3x plus 4 plus n tan inverse b by a, b is 3, a is 2, so tan inverse 3 by 2. So this is 2 square is 4, 3 square is 9, so 13 की power n by 2 e की power 3x sin 3x plus 4 plus n tan inverse 3 by 2. So in this way we can directly write yn. Let us quickly discuss one more example. If y is equal to e की power x into sin x, what is yn? Yn, a is 1, b is 1, and c is 0 here. Right? We can write this as e की power 1 into x sin 1 into x plus 0. So a is 1, b is 1, c is 0. So we can write here 1 square plus 1 square की power n by 2 e की power x sin bx plus c. So here x plus n tan inverse b by a, 1 by 1, tan inverse 1. And tan inverse 1 is 5 or 4. So 1 plus 1, 2, 2 की power n by 2 e की power x sin x plus 5 or 4. So this is yn. Try some more example. Exercise that y is equal to e की power 2x sin x. Find yn. Y is equal to e की power x sin x plus 2x plus 3. Find yn. Y is equal to e की power minus x sin x plus 1. Find yn. So try these example. We will discuss some more examples in the next video lecture. Thank you. Have a nice day.